Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities. And I am one of your hosts, Sarah Chang, and joining me, as always, is Bernie Ryan, DJ Star Watcher. How are you, Bernie?
Yes, hi, Sarah. Very good.
And if you're joining us with the visuals, Bernie is apparently flying with his head outside of the airplane window right now.
Yeah, it's kind of breezy out here.
Are you having trouble with the oxygen, or do you have all the supply that you need?
Yeah, I would have trouble.
Bernie is our professor of the astronomy lab at USM and our local protector of the night skies. Reach out to us at WMPG, scientifically speaking, at gmail.com if you've got any questions, or on Twitter at WMPG SciSpeak. Bernie, could you let our listeners know what is up in the night sky for the coming week?
Okay, good. Yes, excellent. We have a much better than usual week coming up. So this will be Friday, December 11th. So the moon would be a waning crescent, probably coming up around 3 in the morning. But the big thing to look forward to would be the total solar eclipse on Monday, December 14th. Now, it doesn't come over this country like the one Sarah and I saw 3 years ago, 3.5 years, but you can watch a live feed of it. It'll go over Argentina and Chile, pretty much a similar path to the one we had last summer there. That's Monday, December 14th. Basically, it's going to last maybe just a little bit longer than the one we got to see. So you can watch it on the San Francisco Exploratorium site. They have a really good website. They'll send actual people down there. And then also SLU.com, you can watch it on that. I've watched many other eclipses and lunar eclipses, even meteor showers, different things that you can watch on SLU.com. And the other really exciting thing will be Jupiter and Saturn. They're getting closer and closer together. They're less than 1 degree apart now, and they will be less than 1/10 of a degree apart in just about 10 days, actually exactly on the winter solstice. So you probably want to start watching as soon as they become visible around 4:30. You'll probably see it best around 5 p.m. And if you wait till 5:30, they're already getting low in the western sky. So don't wait till then. So around 5 p.m. on the winter solstice, 1/10 of a degree apart, the closest in 800 years. So this will be a really exciting winter solstice coming up, but that's before then. So watch for the eclipse. That, of course, happens at the new moon. It's a daytime event. It'll happen around late afternoon, just about the time the one we drove out west to see. So they might be off by 1 hour in Argentina and Chile. So if you watch a feed of that, they'll be off about an hour. And then if you get up early, you can see Venus around 4 in the morning. So that's basically it for the week. Pretty exciting week coming up.
Thanks, Bernie. I'm curious. I feel like I've been seeing a lot of on popular sites talking about Jupiter and Saturn as if it's like the Christmas star. Have you heard that?
It might have been.
Okay.
It was a Venus and Jupiter triple conjunction in 2 and 3 BC, and then there was something else that happened 7 BC. So that there were 2 possibilities, a conjunction there. The last time they actually went directly in front of each other was like 8,000 years ago. It's called a mutual occultation. So those are much more rare than just a close conjunction. So that was 8,000 years ago. So that wasn't the Christmas star.
Very cool. And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. Bernie, would you do the honor of introducing our guest du jour?
Yes, okay, good. Thanks, Sarah. Yes, we have an excellent guest on today. His name is Jon Wallace. He's actually been with us a couple of times. He has a degree in geology, and he taught college courses, and he's a retired high school science teacher. I remember he gave a really excellent presentation to our club, bringing in his huge collection of meteorites. But today he's going to talk about micrometeorites. So welcome to the show again, Jon.
Thank you for inviting me.
Oh, you're welcome. Yes, you always bring interesting new things, and you're also an expert on the sun. So those are nice to see some of those pictures. But we'll stick to micrometeorites, I think, for this show. We'll have you on again when the sun gets more active and so on. Yeah.
Great.
So, Sarah, you want to start with what a micrometeorite is?
Well, I think our guest should actually tell our listeners what a micrometeorite is.
All right.
No, Jon, go ahead. Yeah.
Yeah, I mean, basically, you can see a picture of one. Let's see, which way? There's one right in the background there, and that's one of mine, and they're very small. It's basically the same thing as a meteor. A meteorite is an object from space that falls through the atmosphere and makes it all the way to the Earth. A micrometeorite is just a microscopic object from space that makes it all the way to the Earth and survives the trip through the atmosphere. Pretty simple definition, exactly the same, just the only difference is the size in terms of definition. It's just a tiny little object. It is not melted off debris. It's an individual object coming through. So there are objects that are formed by melting, but that's a different beast.
At what so what is the kind of threshold to say at this size and below that would be what you would consider a micrometeorite?
Almost all the things that hit Earth are tiny. It's about 0.5 microns, 0.5 millimeters and smaller, down to about 0.1. Anything smaller than 0.1 burns up in the atmosphere. Okay, but between those, this huge influx of material comes in, about 60 tons a day, and that's the stuff I'm looking for. And then it goes down to very, very little, between about a millimeter and a centimeter. There's very, very little material. Again, it burns up. And then at about a centimeter, there's another peak that comes along. And that's the little hand-sized meteorites you see, you know, that I have in my collection a lot of, that fall and you get these little pieces all over the place. And then it goes back down, and then you get a huge peak again where they're really, really large. So you get the really big ones, the little hand-sized ones, and the tiny ones. And the tiny ones outweigh all of them by a huge amount. It's just that they're spread all over the Earth, and they're so tiny that you might get one or two, you know, a few per year. That's it.
Wait, so there's like 3 peaks. It's not a linear curve?
No, it is not a linear curve. In terms of, I'm talking in terms of size versus volume.
Yep.
The amount of mass that's making it here. Okay, mass. So the mass, 60 tons for the micrometeorites. And then if you look at the graph, it's like maybe 10 tons of the 1 centimeter and maybe 20 or 30 tons of the big stuff.
Wow.
But you know, they're coming down in 1 or 2 pieces, you know, big stuff. Whereas with the micrometeorites, you're getting billions, you know, being rained down.
Right, right. So just like regular meteorites, there's all these different types of meteorites. There's also different types of micrometeorites. So I actually, I think there are 5 or 6 that I found. So I guess the first type is quote unquote unmelted, which
Right.
probably we wouldn't find here on Earth. It would.
Well, actually, they have been found on Earth.
Oh, okay.
Yeah, yep. And actually, Jon Larson, who's the world expert on finding these in cities, has found some. But before that, they were found in Antarctica. That's how we know knew they existed. And then they've been collected up here. You know, NASA has that jet that they fire up there to collect it, and they use aerogel to collect. Found some up there. They're very kind. I am. You know, they're almost impossible to find on Earth. So,
Oh, okay. Wait, so you said NASA had used what kind of jets to
you know,
find
some
them?
of the other types that, oh, they have a jet that can fly way up in the atmosphere, a special jet that can fly 50,000 miles up or whatever, way out in the stratosphere, and they're collecting with aerogel. That's that extra airy, it's the lightest substance that on Earth. It's a man-made substance, and it's designed so that particles can strike it without breaking apart. It's incredibly, yeah, it's airy. I have a piece in the other room, but it's like, it feels like nothing, you know. It's yeah.
Very
but
cool.
It's really strong too. It's very difficult to compress. So it's interesting stuff.
Gotcha. So
NASA
unmelted, so unmelted micrometeorites are very, very rare. You'd have to go either to Antarctica or you have to go way up in the you'd have to go to the stratosphere to get it. So then the second micrometeorite type, and I'm probably gonna butcher this name, but scoriaceous, is that it?
Scoriaceous. Yep, scoriaceous. It has little holes in it. If you've ever looked at volcanic rocks, they have bubbles that explode. And so they get these little air bubbles all over the place. And that's what scoriaceous is. I've found one of those myself. They're really hard to find too. The scoriaceous is, just something with holes in it. I can send you pictures along of the ones I have.
So then the third type that I found based on temperature also is the porphyritic.
Porphyritic. Yep, I found a couple of those. Basically, what happens is the thing is coming through, and part of it liquefies and becomes a glass. But there are these big crystals of a mineral called olivine, and olivine is found in volcanic rocks a lot. It's very high temperature tolerant, so it can exist in high temperatures, and so the crystals don't melt really, so they're floating around in this glass, and in the 3 to 8 seconds that that micrometeorite is actually melting and then cooling back down, they form these little blobs sticking out. So you see the little crystal faces sticking out of the glass. And so it's kind of a weird looking little glassy object with bumps all over the place. It's kind of an interesting little object.
Yeah. So I'm curious, I've seen certain micrometeorites that have this almost a shape that looks like it's been elongated, and they use this word iron beads at the top and at the bottom. Is that specific to a temperature or a specific type of micrometeorite, or does any?
Well, what's happening is if there's iron in the material that's coming in, when it melts, the iron melts fairly quickly and forms a little bead. And those iron beads sometimes have other metals in them too, like platinum and gold and things like that, some of the rare earths. And platinum's pretty common. Sometimes they form spheres, sometimes they're blobs sticking out the end. And as it's coming in, that metal bead is very, very dense. And so it ends up coming out sometimes to the edge, the front edge of the micrometeorite as it's falling. So that's why sometimes you can see them. They're not in the center anymore. They're offset. And that part where the metal bead's sticking out is actually the front of the meteorite.
Wow.
As it was falling.
I'm curious. I mean, it almost sounds like it's like iron from within the material that is beating up, and then it's coming out on the surface. Could it ever detach and just be a single floating iron bead that is falling outside of its former shell or home?
Former cells.
Yep, that happens. It's density that's pulling these things together. So, iron and platinum and stuff are very, very dense. And so they form this blob because of their density. And then because they're so dense, they actually come toward the front edge as it's falling. And like you said, they can sometimes escape. And so you see big holes sticking out the front. I actually have one in my collection that has a big hole sticking out of it, showing up where there was a bead that escaped.
Oh,
yeah.
Very cool. Very cool. So then I guess
Yep.
this might be a question for afterwards. If you're trying to then find these micrometeorites, I think I've seen that some people use very high powered like magnets to find them. You wouldn't be able to find the body that it's separated from, right?
I'm not sure whether that's true or not. I have a feeling that as it is ejected, it probably does vaporize, but it's possible it could make it through, but it depends on where it is ejected, at what point in the orbit it's ejected. But
Sure.
I don't know of anybody that's found one of the little ejected cores. So
All right. So another type is barred olivine. So you had mentioned olivine. How is the barred olivine
yeah,
different?
and they're the most common. Like I said, most of the ones are the ones at the higher temperature end that we can actually tell by their melt pattern and the
Yeah.
aerodynamics that happen because of that.
Yeah.
Again, it's partially melted. The olivine crystals, we talked about olivine being high temperature so they can survive. And so what they do is they line up in parallel plates, and that's why they call them barred olivine. If you slice through it, it looks like a bunch of bars of crystals lined up. And so, you know, that's where that name comes from. It's just a type. And then they're the ones that have the really cool aerodynamic features, because the surface recrystallizes and it's affected by the aerodynamics. So you get these kind of feathery crystal growths and things like that over the top, which is kind of fascinating to me anyways.
Is that the one that people call like a Christmas tree kind of?
They do have Christmas trees in them. There's a few others that have real tiny Christmas trees in them. But yep, there are usually Christmas tree magnetites in the surface of these, that particular kind. Yeah,
Neat.
exactly.
So then the next type is a cryptocrystalline. Is that right?
Yeah, they're the little tiny crystals, dendritic crystals they're called. Dendrite just means like a tree. And so they're little dendrites that form on the surface. The little magnetite, they're iron oxide, come out on the surface and crystallize.
And so that's one of the higher temperatures. And so this is what I got at the highest temperature was glass. Is that like the high end of the spectrum for
Glass is the, yeah, glass is the highest. That's where totally melted. And you know, we didn't talk about it, but these temperatures are basically based on how they hit the earth. The earth is turning, and if you're going with the flow of the earth in the direction of the earth, you don't heat up much. And if you're going in the middle, that's where the ones that I can find are that the things that have aerodynamics, they partially melt. And then if you're going against the direction that the earth is moving, that's where you get the most friction. And so it melts the most, and that's where the glasses are formed. And those form almost perfect spheres. Sometimes you find them with little metal beads. I haven't found any yet. I'm still looking, but that's where that would be found. Very high temperature, 5,000 degrees Fahrenheit, roughly 2,000 something, 2,800, something like that centigrade.
Yeah, the different showers have different characteristics. Like the Geminids would tend to be slower because they're caused by an asteroid. Actually, the Geminids are coming up this week too, December 14th, along with the eclipse. So they tend to be denser and smaller, and they won't leave the long trails and they won't break up as easily. And then others come in with the rotation, so they're slower. Others come in against the rotation, so they're coming in faster. So just like John said, yep.
The micrometeorites are actually associated with something called the zodiacal light. And so they're not really associated with meteor showers. The meteor showers are material that's melting off or burning off a comet or being blasted off an asteroid. Most people think that the micrometeorites are actually pristine material that is floating around individual. They don't break up. It's not stuff that's breaking up. There are things that we know of that break up. I have a few, they're called ablation spheroids. That's when it melts off a meteor, you get these little tiny round blobs that make it to the earth or that are found around a meteor crater. And those are ablation spheroids. And they're very similar in size to the micrometeorites, but they have different characteristics. So, yeah, the micrometeorites are zodiacal light is the dust between the planets, basically. And that's where this stuff comes from.
So speaking of characteristics, you often search for them. What do you look for? Where do you go, and how do you actually find them?
The best place is to find a large flat roof where there's lots of debris and hasn't been touched in years. So you want lots of stuff up there, and you just sweep it up. And if it's dry, you take a magnet through it. Most of these micrometeorites are magnetic. And so you take a magnet through it, and put it in a baggie, take it home. I then wash it in a bucket with some laundry detergent and wash it really good, try and get all the leaves and organic stuff out. And then I let that dry completely, and then I put it through some screens to get it to the sizes that I want, things that I think would be easier to search. It's hard to take real tiny particles and large particles in the same sample and try and find what you're looking for. So if you get them all about the same size and search. So that's it in a nutshell. I mean, and people want to contact me, you know, they're more than welcome. I'd be willing to help people try and do this. The museum over in Bethel, the Gem and Mineral Museum, is trying to find them. And I went over to help a friend of mine who works there. And we searched a theater roof. It was really wet, so we didn't get a lot of material, but I have found a couple of micrometeorites there already. So, you know, they're up there. It just takes a long time. I think my average is around 30 hours for one, each one.
Wow.
So
Wow.
just diligence, you know.
And you'd
putting in
have
the time.
to, are you looking at them under a microscope to
Yeah.
confirm?
Yeah, so I first look under a low power microscope, one of those dissecting scopes, about probably between 20 and 40 power. And I pull out a whole bunch of stuff that look good. You know, you can't tell under that magnification. And then I put it under a high powered microscope and take a look there. And then to really tell, the secret is you need to photograph it with a special technique called focus stacking. And that just you take hundreds of images of the same thing. If you've ever looked through a high power microscope, you know, only a thin layer is in focus at a time. And so if you take images of all the different thin layers and run them through a special program, it puts all the images together and makes one in focus object. And that's the key to being able to identify these really well.
Can we, is that the only way to identify micrometeorites right now, is through optical means, or are there other electronic or?
There are others, but you have to have even more expensive equipment. You know, you're talking scanning electron microscope and EDS, which is a type of chemical analysis using a scanning electron microscope. And that's really not a normal thing that you or I are access to. So us, yes, it's the only way. But research
wait,
people, that's
John,
what they're
you're
using.
telling me that you don't have an SEM in your basement?
I know, what the heck, huh? I wish.
So I'm curious, John, I know that we kind of talked about the types and we talked a little bit about the features, but is there anything that you're like really looking for? I know that, you know, for people who hunt meteorites, you know, you're looking for something that has a relatively smooth surface. And I think one of our meteorite guys before had mentioned that some people bring false, you know, rocks that are just painted black, and they try to, you know, try to sell it like it's a real meteorite. But is there anything besides, you know, some of the glass beads or things like that, or the holes that we were talking about that you're looking for?
Most micrometeorites are not perfectly spherical unless they've completely melted. So the ones we're looking for are spheroidal. They have little bumps on them, little features. It's basically looking for different structures. The porphyritic, you're looking for bumps sticking out of glassy things that are sort of spherical. The barred olivines, you're looking for these parallel lines, and then over the top of that are these aerodynamic features. And you know, some of the other ones are a little more difficult, the glassy ones, things like that. You really need to take that image and see what it looks like to see if it has any of the features that you're looking for.
I came across the cryptocrystallines and the ones with the nice little features, the crystals on the outside. You know, I saw them as works of art. I mean, it's just amazing.
Oh, yeah.
To learn scientifically and artistically about these things.
Yeah. The exhibit I put together was an art exhibit, and I did my photographs and told them about what it was about. But it's really beautiful, beautiful pictures, I think. They're gorgeous objects. And that's one of the reasons I search for them. Unfortunately, the biggest problem I have is finding people to let me on their flat roof. Can you believe that?
Yeah, I know. You keep asking me if I know anybody with a huge roof, and I
Yeah,
don't. Yeah.
nobody
Wait.
lets me on their roof. Wow, what a
Hmm.
concept, huh?
Yeah.
But have you at least tried out the USM parking garage?
I have tried the parking. The problem with parking garages is you get all the rust and stuff from cars that are rotting out and sand trucks and things like that. So you get a ton of stuff. So instead of being one for every meter, it's like one for every garage. You know, it's spread out. It's phenomenally difficult. I haven't found one yet. I looked through a bunch of it when I first started, and it was just so difficult.
Yeah. So speaking of, the why, I know you covered a little bit like how beautiful they are, but why else do you do this? Like what, is there a scientific endeavor?
Oh yeah. Um, there's a bunch of reasons. One of the big reasons I think is because these are thought, like I said, to be pristine material it's just floating around and then it drops to Earth. So this is uh, even better than meteorites because meteorites they formed into an asteroid and then were blasted off. So you've got all this formation stuff happening, all kinds of stuff happening. These things, when they fall to Earth, they were pristine material. And so we can tell a lot. And what most of the people are finding is that they're very similar to the very primitive meteorites, the carbonaceous chondrites, they're called, the oldest. They go billions of years old, and so they go back to the beginning of the solar system. And these are even more pristine than those carbonaceous chondrites, and so they're providing material that we can't get any other way without going and collecting out in space.
So as we close our show, John, for those who might be interested in pursuing this as a potential endeavor and to learn more, one, how quickly do you think somebody could find one if they followed your general protocol that you laid out? Essentially, how quickly did you find yours when you first started to do this? And two, what are other resources that they could go to check to learn more?
Well, I'll start with the second one first because the best resource is Jon Larson's Facebook page, the Project Stardust. He's got all kinds of stuff there. He's also written a few books about it. If you're interested, they're not terribly expensive. Amazon has them. They're less than $10. The other one, when I first started, my first one took me 70 hours to find, looking under a microscope. So it's not easy. And the second one took 30. So it was 100 hours for the first two. And it hasn't got a whole lot better than that. My fastest one was 11 hours, I think. So it's not an easy process. You can imagine looking through millions and millions of tiny sand grade sized things to try and find one particle sitting in there. So it's a challenge, but to me, it's not just the challenge. It's being able to find something that no one has seen before, that's from the very beginning, and you're finding it yourself somewhere, right in the middle of downtown or whatever, so it's just the excitement of finding something that no one has found before. And as Bernie said, they're absolutely gorgeous objects. And, I find them fascinating, and there's so much that can be learned from it. And I'm hoping to be working with people from the University of Maine, Orono, and Colby in the spring if COVID go, and getting some SEM, the scanning electron microscope time and things like that to try and learn a little bit more about what I've got.
Well, thank you so much, John, for sharing about the what and the why and the how of micrometeorites. You have been listening to Scientifically Speaking here on WMPG with myself, Bernie, and Jon Wallace. Stay tuned for Sports Jam with Cullen and Connor. And from your favorite nerds, mask up, and we wish you healthy bodies and clean air. Lastly, are we here in Maine kind of in a good position for micrometeorites, or is there some place on Earth or some latitude, longitude that's really better for finding them?
Well, when they've done actual studies of these, where they're finding them up in the stratosphere and stuff, they're raining down in all directions. So there is no real golden spot. People have found them all over the earth. Now, people like me are all over the earth, and you get pictures from people from, I know there's a guy in Minnesota, there's one in New Mexico, there's a lot overseas in Germany and places like that. And everybody that searches for them for long enough finds them. So they're all over Earth. And just like the meteorites, they're scattered randomly all over the place. So it's just a question of going out, putting in the time, and hoping you have some luck to be able to find the one that's in your sample.
Awesome. John, can you sell these micrometeorites?
John is selling them. Yeah.
Oh, okay.
He sells them for $100 a piece.
Oh, wow.
Well, it's
seems
30
crazy.
hours of work.
Yeah.
Crazy, but
That's only $3 an hour or something, right?
well, for me, yeah, but he's gotten to the point, he's been doing it for, he found his first one 11 years before 2016. So that's 15 or so years, whatever. And so he's been doing it for that long, and he's got thousands now.
Yeah.
He's collected all over the world. So he's got thousands and thousands of them. And, some of them are pretty common. So he sells them off and, makes money. But, it's not really a burning business. There aren't thousands and thousands of people clamoring to get one. Ooh, can I have one? I want to see this tiny speck that I can't even see.
Yeah. I mean, right. If you don't have the microscope to really appreciate it, it's not much.
Yeah, I mean, you saw how small it was,
Yeah.
It is minuscule. It's
Right.
3 times the thickness of a hair, they're
Wow.
pretty darn
Yeah.
small. So
Yeah. Yeah, like the meteorites you can see, and you can get those
Yeah.
for $30 or whatever. So you can
yeah, oh, you can get those cheaper than that. I mean, a few bucks on eBay,
Yeah. Yeah.
So, yeah.
I guess I was also thinking that collecting micrometeorites is less of a space hog than collecting meteorites because of how small they are. How do you store them when you what is your method of storing?
Well, that picture that I showed, I think you got to see it with me holding a little tiny clear gem jar, the little screw cap thing with the little tiny white patch with a tiny black dot on it. That's what I store them in, gem jars. They have screw caps, so if I drop it, I don't have to worry about it. It's in there somewhere, I can find it. And the white stuff is actually, I use double-sided tape, and then I stick sticky pad. The white stuff is sticky pad with the sticky surface up. So I stick it on the sticky pad, and it holds it on without gluing it on, if you will. It can be taken off or on easily, but it keeps it from falling around, bouncing all over the place. And so, it's just an easy way to store them. So yeah, they're very small. It is, my wife likes it. My mineral collection takes my micrometeorite collection, the whole collection fits in a probably 5 by 5 box. It's just pretty small. I've got 28 and they all fit in there easily, not a problem.
Yeah, no, that's I guess if there was some kind of micrometeorite convention, it would be the most lightweight convention ever.
Right.
You wouldn't have to be lugging around boxes and boxes of things.
Yeah. I mean, I go to the Newry Mineral Show, and there's the people that are unloading vans and vans full of stuff. I'd be pulling up with a small box, it's like, oh, here
right
it
out
is.
out of your pocket.
Right here's my collection right out of the pocket. Yeah, pretty fun.